Hello, everyone. So decided to make this video just to accompany the, I guess, the lesson for students that were absent and for students that felt like their computer was lagging or if the material was just hard as in itself. So what we're going to be doing today is called evaluating piecewise functions. Pretty much you will get a piecewise function, which is a function that has been broken up into parts, and you get to evaluate a point depending on what corresponding part there is. Also, if you could leave some feedback in the chat, because I'm using a different mic, and hopefully that makes it sound better, or if it just makes it sound worse, let me know. Alrighty, so let's go ahead and begin. I like to start my lessons with a warm-up. So keep in mind you have this in your table of contents. Put the number, the title, and whatever page you are working with. And that helps, especially when you have to study for an exam. You look at table of contents. Oh, unit 1 is for, and then whatever section you feel like you need help on. Okay, so the first one is a little warm-up to remind us what we just learned the days before. So take a second, pause the video, work it out, and then resume. Awesome. So the best thing to do here, I know it's a lot better when you have a piece of paper, but here you can already see that this part right here, you can see that if this was like a roller coaster, it would be going down, right? It would be decreasing. So this is decreasing. Similarly, you can look at this one. I'll make it blue. From this point, the roller coaster is going up in height, or the range is going up as in positive values. This is increasing. All right. And we can continue doing this by noticing that it is decreasing right here as well. Right. And it gets that little dip, and back again it goes up, and we can see that it is increasing. And I didn't do it, but it keeps on increasing to positive infinity, and the same thing goes on the left hand side. It is also here. Okay. Another thing I like to mention is that there is points right here with the increasing and decreasing changes. So specifically this one right here, it decreased and then increased. So hopefully you can see that's like a little dip. This is a minimum. Over here, we got the increasing change to decreasing. So this is a max. And right here, we can see that it decreased and then increased. So that is a minimum. Min. And it appears I forgot to not label these. So these are decreasing. And this one on the right is increasing. Sorry about that. Okay. Now, we learned on Friday that there's a difference between minimums and there's a difference between maximums. So these extrema, if you will, these can either be local, meaning that there's many of them, and there's places on the graph that either go higher or lower than it. But there's also absolute, meaning these are the absolute highest or their absolute lowest. So this right here, this minimum right here that I'm working with, this one right here, hopefully you can see that there's nothing lower than this graph right here. So this is an absolute minimum, because there's nothing in the graph lower than this, and you can trace it, and no matter what, this is the lowest part of this. How about this maximum right here? This max right here, you can see that there's parts of the graph that go way higher than this, specifically these right here and these right here. Those are all points higher than this. So this must be a local, because there is higher parts in the graph. All right, this minimum right here, as we said before, this right here is the lowest we can go. So this must be a local min. They're both minimums, but one is lower than the other. Okay, and the lowest part is absolute. Okay, so let's go ahead and find the minimum. It's the first question it's asking me. And notice I have two. Since I don't have any y values, I can go ahead and state that this right here is just my x value. So my x value is when x equals -3. Hopefully you guys see that. So absolute minimum is when x equals -3. And I got another minimum right here, and my x value, according to this, is this right here, when x equals 2. So when x equals 2, I have another local min. Sorry, a local min at x equals 2. Okay. The next part that we're going to go ahead and work with is the interval of increasing. So let's go ahead and see the increasing is all of this area, all of this part right here. And we can see that it's all this blue part, right? And from this part all the way to this arrow is telling us that it's going both positive infinity on the domain and on the range. So let's go ahead and find out what is the interval that includes all of this right here. So I know I made it messy with my marker, but pretty much what I'm saying is from here to here, the x values. So from here to here, that is going to be the values -3 all the way to 0. Is that the only place it's increasing? Well, let's go ahead and use our highlighter. We see that it's increasing right here from 2 all the way, and the arrow's telling me it's going to go all the way to infinity and beyond, right? So it's going to be union from 2 to infinity. That's all the places it's increasing. All right, last but not least is boundedness. So is this function bounded? So keep in mind this only occurs when you have an absolute extrema. So in this case, my absolute extrema is right here, this absolute min. And we can see that if we were to draw a line right here, this function would not pass it. Like the lowest it can go is this right here. So this is bounded below. Bounded below. Similarly, if I was to draw a line right here, would this function pass it? Yes, it would, because this is telling me it's going to go to infinity, and this is going to tell me it goes to infinity. So it is not bounded above, just below. So this answer would be bounded below. Awesome. Alrighty, there is a quiz on Thursday, and I said that during class, but hopefully this is a nice reminder. Okay, so as I mentioned, we are working with piecewise functions. What exactly does that mean? Well, pretend all of this blue graph and red graph were all one function of x. We can see that if I was to get, let me get my laser. If I was to do the vertical line test specifically at any value here, well, literally any value, but let's look at this one right here. At 1, when x equals 1, we can see that the function would pass at 2 points on my y value, and that we can't have that. So therefore, this is what occurs. We have to go ahead and limit the graph. So notice how if I go ahead and stop that quadratic function, the x squared, it does not overlap anymore. Just ignore this right here. It does not overlap anymore. Like it will pass the vertical line test everywhere. So that's ideally what we're going to go ahead and do. And here's another example that we limit the functions, make them like pretty much as it sounds, piecewise pieces of the function by limiting the domain. Okay, so this is a nice little visual of what occurs. So what I want you to know is the piecewise function will be broken up into plenty of other functions. In this case, we have 3, but you can have many more or less, if you will. And what we're going to go ahead and do is you're going to go ahead and see that these parts are restricted to their own individual domain. So for example, the S function, right? The S function is only associated to when x is less than a. The R function is only associated when x exists between a and b, and the T function only exists when you are greater than b. So that sounds very confusing to me, but in reality, you can go ahead and make a little table. You can put your A, your B. Oops. Just kidding. You can go ahead and make your A, your B, and you can pick where these functions occur. So let's go ahead and see that. What does this little symbol mean? This little Pac-Man symbol, x is less than a, so meaning you're looking at all the values that are less than a, meaning all values less than a, or if you're looking at the line, which are to the left. So this would be my function s of x. Alrighty. Similarly, we can look at this one when the values for my function r, are between a and b. This is going to be my values between a and b are right here in our number line. Now, I'm going to go ahead and talk about this right here. Hopefully you remember for algebra 2, this little equal sign means that it's all the values between, the values that include a, so a all the way to b, but it does not include b, just to up to b. Okay, last but not least, let me probably pick a different color. All the values that are greater than x and equal to b. I'm sorry, equal to b. So it's going to be, if you're looking at the number line, this is t of x. So all the numbers that are bigger than b or equal to b. So this would look like bracket b to infinity. So be aware, you're going to be asked some of these scenarios right here. This is some practice problems. So same thing. If you were to go ahead and do this, I told my students to look at this first, and they make a number line, and they put that value here, 0. Okay, so they're going to decide, is it to the left, is it to the right of that value? So this right here, x squared plus 1 is less than 0. So less than to me means to the left. So all of this x squared plus 1 is on the left, is less than 0. Awesome possum. All right, the next one. X plus 1 is greater than, keyword equals to 0. So that is x minus 1. And that is including the 0. So to the right, and it is included in 0. So includes 0. Not to be confused with the increases, sorry. And all you have to do, guys, is substitute the value accordingly. So this 3, the 3, where's the 3 in our number line? Well, the 3, let's say it's over here. So if it's on the right, it's on the right, I'm going to use this one. It's the same thing as looking at it here. I'm going to use x minus 1. So x minus 1, I substitute the 3 into my x because that's what they want me to do. X minus 1 equals 2. 3 minus 1 equals 2. That is my answer. So when at f of 3, if I substitute it, I got my answer to be 2. Let's try it one more time. F of 2. If my f is 2, I go ahead and check at which value of this. Actually, let me change that to a negative 2. I know that's going to be different from our other. So f of negative 2, just to switch things up. Okay, f of negative 2. I go ahead and check, where is my negative 2 on my graph? Is it on the left? Is it on the right of this number line? So hopefully you can see that your negative 2 is on the left, right? Negative 2 is a negative number smaller than 0. So I'm going to go ahead and use this one, which says x squared plus 1. So it's negative 2 squared plus 1. So negative 2 times negative 2 plus 1, quick maths, gives me a positive 4 plus 1, which gives me 5. All right, last but not least, which value includes 0? Which one of these two functions, my left or my right, lets me equal to 0? So hopefully you can see that the only one that equals to 0 is the one on my right, because it has a little equal sign right here, the little bar. So I'm going to use that equation, which says x minus 1. So 0 minus 1 equals negative 1 for my f of 0. Alrighty, go ahead and try this one on your own. Very similar to what we did in class, but hopefully seeing it twice helps out a little bit better. So go ahead and pause that video and try it on your own. Okay, so hopefully you tried it. And we're gonna go ahead and see that I'm gonna put these number lines. So the values that I have is x less than 1 and x greater than 2. So I'm gonna put those on here. So 1 and 2. And then I'm gonna decide, I'm gonna decide what is going on, right? So when x is less than 1, less, that means to the left of 1. So this is gonna be 3x. The next one says, pick a different marker, purple, x is greater than 2. So that is on the right. So this is on the right. So this equation right here is going to be on the right of 2, 2x minus 1. Okay. So let's go ahead and evaluate this. Sorry, guys. I forgot to mute this thing. All right. So let's go ahead and see. 0. So 0 is in what value? So 0 is on the left, right? Because 0 is right here. On my number line, it's to the left of 1. It's smaller than 1. So I'm going to substitute it into the 3x. So it's going to be 3 times x. But in this case, my x is a 0. So now it's 0, settle. Alrighty. The next one, let me pick a different marker. Let's pick green. Negative 2. Negative 2. Where is negative 2 in my number line, right? So negative 2 on my number line is to the left of 1 because it's smaller. So I'm going to be using, again, 3x. But instead of writing x, I put my associated value, which they told me is a negative 2. So it's negative 6 as my answer. And last but not least, when x equals to 5. When x equals to 5, I go check my number line. The 5 is right here and 2 is right here, right? So I can see that 5 is to my right. So therefore, I'm using this equation, 2x minus 1. And all I have to do is substitute 2 parentheses minus 1. What goes into the parentheses? Well, they told me it is 5. That is 10 minus 1, which gives me 9. And if you want to write it correctly, it's f of 5 is equal to 9. Okay. Alrighty. Let's go ahead and do this one a little bit quicker, since I think I'm getting on the 20-minute mark on my video. So no good. Okay, let's do this right here. So I have my number line, right? All of this told me what exactly to see. And I see the number 0. I see the number 1. So I'm going to put 0. And I'm going to put 1. And I'm going to decide where each function goes. So when x is less than 0, that means on the left of 0. So this is going to be to the left of 0 is x minus 2. When x is between 0 and 1, right? Including 0. Sorry, let's not forget that. So including, I should probably do a different marker. Good idea, brain. Okay, so, ooh, can you see that? That's orange. Ooh. I'll do green. Okay, so this one is going to be including 0. It says it's going to be this function right here, which is 2x. And the next one says, let's do red. When x is greater than or equal to 1, so I'm going to put brackets because it includes it. When it is to the right, it's going to be x squared minus x. Okay. So we're going to go ahead and do this real quick. So if it's 0, I'm going to check on what part of my number line it is. So which one is equal to 0? Which one of these 3 is equal to 0? Is it the left? Is it the middle? Is it the right? Well, hopefully you can see that this has a little equal sign. So therefore, it's going to be 2x, the function that I'm going to use. And it's going to be 2 times 0, which is 0. So this is 0. If I went a little too fast, guys, you can just pause and rewatch it. But hopefully it's just substituting. The hardest part is finding out where these go, right? -2. Where is -2? Is it on the left of 0? Is it between 0 and 1? Or is it bigger than 1? So hopefully you can see that this is the smaller than 0. So I'm going to be using, again, this right here, x minus 2. So it's going to be -2 minus 2. That gives me a -4 when f of -2 is evaluated. All right, last but not least, f of 3. Where is 3? Is it to the left of 0? Is it less than 0? Is it between 0 and 1? Or is it to the right? So which hopefully you can see that it is to the right of 1, right? 3 is all the way here. So I'm going to use the equation x squared minus x. And wherever I see x, I'm going to substitute the value that they told me, which is 3. So it's 3 squared minus 3. That is 9 minus 3, which gives me 6. So f of 3 is 6. All right. If you stuck with me to this video so far, I'm going to go ahead and show you that I'm going to give you a couple bit of homework answers right here. So let me go ahead and put this over here. This is homework 7.4, question 2. So I got x squared is right here, and I got x minus 4, and those two little bars, what the heck is that? Well, hopefully you remember that that is absolute value, which is pretty cool. Okay, so we got this restriction right here, right? We're going to go ahead and see them. -7 to 2. So let's go ahead and write that. -7 to 2. Okay. It's going to be pretty good. So whenever the function is between -7 and 2, I'm going to be using x squared. So whenever it's between -7 and 2, I'm going to be using x squared. Easy peasy. Now, they're telling me something else. When x is greater than or equal to 2, that means to the right of 2, I'm going to be using absolute value of x minus 4. Because remember, this is greater than 2. And it is including 2, so I'm just going to put a bracket just to remind myself. And we're going to substitute. The first one says h of 2. Where is 2 in this one? Well, it's on both, right? But only one of them tells you that it's included. And that is the one with the little bar. So I'm going to be using this right here. Because the only one that includes 2 is my absolute value of, right? So I'm going to be using to find h of 2. I'm going to use the function x minus 4 in the absolute. So I'm going to substitute 2 minus 4 in the absolute. So 2, you take away 4, that gives you -2, but it's in the absolute, which gives you 2. The next one says h of 5. So 5 in my number line is this way, right? It's bigger. It is on the right-hand side of 2. So that's going to be right here, which means we're going to be using this equation again. Let me pick a different marker. If it is bigger than 2, use this one. So it's going to be x minus 4 again, and we're finding h of 5. So it's going to be 5 minus 4. $5 minus $4, that's just $1 in the absolute, which is still just 1 because it's positive. All right, last but not least, I got h of -3. All right, so let's go ahead and see. Where is -3 in this entire number line? Well, hopefully you see that -3 exists between -7 and 2, right? Because all the numbers between here are 2, I'm sorry, not including 2, close to 2, 1.99, 1, 0, -1, -2, -3, -4, -5, -6, -7. So -3 is right here, right? So I'm going to use this equation, which is x squared, which is here. So notice how like that number line really helps. So x squared. So instead of writing x, I'm going to put -3 squared, which gives me -3 times -3, which gives me 9. So h of -3 is 9. Awesome, guys. So I would go to my digital notebook and put my answers 2, 1, and the 9. Alrighty. So that's all I have for you guys. Hopefully you enjoyed that little solution as well. And that would give you like at least 2 more in the homework. I believe 2 or 3. I didn't do that much since it's a Monday. Alrighty, if you do have questions, guys, go ahead and ask me in class or through the chat box or on the comments, and I'll get to them. Other than that, thank you for watching. Laters.